Hello, my name is Oktay Dede, and this is my presentation for the midterm project for IoT class. Uh, for this project, I have developed a plant humidity monitoring and control system using a Raspberry Pi, Pico, and DHT22 humidity sensor and servo motor and the common cathode RGB LED. Uh, the purpose of the application is to monitor humidity levels in the plant soil and or the air around the home plants and give visual feedback and control the watering system using a servo motor. This helps maintaining the ideal environment for plant growth. When the humidity is too low, system indicates the need for watering and activities. Uh, a servo motor simulates the watering system, and the RGB LEDs shows the environmental humidity. When it's red, it means humidity is too low and plants need some watering. And when it's green, it means everything is in good condition. And the other step is when the RGB LED is blue, which means the plants are over watered and maybe need some maintenance. So in this project, the components that I used is Raspberry Pi Pico W as a controller and the HT22 humidity and temperature sensor for measuring the humidity, servo motor to control the water wall, and an RGB LED to indicate the status for visual indication. So, in this project, I set the humidity level as 40% for threshold, and when the humidity goes under the 40%, the LED turns red, and the servo motor goes to 90 degrees, which means it activates the watering system. If humidity is between 40 and 70%, the LEDs turn green, which is the perfect conditions for the plant. And when the humidity is about the 70%, the LED glows blue, which indicates excess moisture, and servo stays closed, and maybe further actions needs to be taken. Uh, so. Let's go with the design of the circuit. Uh, I used walkwire to simulate the environment. Uh, in the walkwire, you can choose the humidity level directly onto sensor, the HT22 sensor in real time. Based on the humidity levels, we will see the LEDs are turning red, green, blue, whatever. Uh, let's start with the code. This code is written in Arduino language. The only addition is the DHT library. We can see here DHT sensor library. I need to edit that one. And also servo library. I have added to control the servo. I have used the uh, sorry digital write uh, digital write commands for turning the RGB LED on and off. Um, let's go with the simulation. Currently, the temperature is set to 24%, and I have serial printed the current humidity level. And as you see, the LED is currently red. Let's change the humidity levels like to 44%, which is perfect condition for our plant. Uh, yeah, we need to wait a little bit because the simulations clock is a little bit slow. Yes, as you see, now humidity is 44% and the LED turned to green and the servo motor is closed. Let's go back to some humidity levels. Uh, let's wait again a little bit. Yes, now the humidity level is below threshold and the wall valve is opened, which will provide the watering system from above, and the humidity sensor will check the current humidity. Yeah, let's give loss of humidity to system like 92%, which is humidity is too high, and let's wait a little bit more. Yeah, the LED turned blue, and the valve is closed. There is no watering needed at this point, and it indicates the overwatering in the system. So let's go with the code. Yeah, first I have defined the libraries and the pins that are required to connect both the DHT humidity sensor and the RGB and servo. And I have defined the thresholds for humidity levels, and I have defined the sensor and servo. In the setup phase, I have initialized the serial as with the baud rate 115,000, and I have printed a initial print that this is an homework project. Uh, the next thing to do is setting the RGB LEDs pins to output mode, which is required. And at the setup phase, also we are initializing the servo. In the loop phase, the constantly checking phase, which is the loop phase, we are always reading the humidity level from the HT sensor. Uh, so this is a redundancy check, which means if reading from DHT humidity sensor is not okay, if there are some problems, it prints fail log. And in the next phase, I am printing the humidity level in each loop and checking the humidity if it is low than the threshold that I set. It changes the RGB values. It When it's low, it turns on the red pin, red RGB red light, and I write the digital write commands writes the red pin as high and the others as low, which provides only red red light to come out from the LED. And also we are activating servo, turning it on to 90 degrees to activate the watering system. And in the other case, when the humidity is okay and the humidity is too high, uh, we need to turn off the servo. So this function, plant servo write 0, ensures the servo is at 0 degree and valve is closed, so no more watering. And I am changing the light accordingly. For example, in the normal humidity phase, the green light is high, others are low, which means uh, the green light will be shine. And when there is high humidity in the system, I'm also closing the servo, which means no watering again, and the blue light will shine. So I have changed the humidity to like 55% in here. And Let's wait a little bit. Yeah, it's now green and humidity is, as you see, is 55%. Yeah, in conclusion, this project demonstrates how simple components like sensors, basic step motor, servo motors, and LEDs can work together to create a smart environmental control system, like in this case, humidity control system. Uh, this is a practical solution for plant humidity control, and I am planning to improve the project in the upcoming phases. Uh, Thanks all for listening. I think that's all from today's presentation. Thank you.